Today we'll be discussing how to migrate a standard GPU model onto Intel's Gaudi AI accelerator. Today's objective is to focus on migrating a model onto the Intel's Gaudi 2 AI accelerator. We will accomplish this by introducing the Gaudi 2 and model references, a list of models running on Gaudi, and we will proceed with a migration example of a computer vision model. Now we can discuss Gaudi 2's architecture. It is an AI accelerator specifically designed for large-scale training and inference. It has 24 tensor processor cores, 96 gigabytes of high bandwidth memory, and 24 100 gigabit Ethernet ports, all dedicated for deep learning at scale. This is paired with our Synapse AI software suite that has been built for both training and inference. We support frameworks such as PyTorch and TensorFlow in our framework integration layer that gets sent down to our graph compiler, communication libraries, and drivers. This has been optimized for deep learning with minimal code changes. And if you want to do further optimizations, we support developing your own custom kernels. For ease of use, we have developed Docker images for both PyTorch and TensorFlow that comes with our full software stack. Now we will focus on model migration using our GPU migration toolkit. We developed a GPU migration toolkit to help migrate over models built on GPUs over to our Synapse AI software stack. The toolkit maps specific API calls from Python libraries and modules like Torch CUDA, Torch API with GPU-related parameters, Apex, and PyNVML. It is pre-installed in our software stack, and to investigate what is occurring underneath the hood, you can enable the GPU migration logs environment variable. Here is an example of a manual migration of a PyTorch model. There are 5 steps to migrate a model. The first step is to remove any CUDA calls. The second step is to import the Habana Torch libraries. A third step is to add htcore markstep, which will trigger a graph compilation to handle large models. The fourth step is to move the models, tensors, and ops to run on HPU by setting the torch.device to HPU. The fifth step is for distributed training to use a Synapse AI communication library, HICL. With the GPU migration toolkit, instead of 5 steps to migrate a model, it only takes 2 steps, importing the Habana Torch libraries in GPU migration toolkit and adding the htcore marksteps. The migration toolkit has 3 classifications for API migrations. HPU match is a one-to-one match where we can replace CUDA calls with HPU calls. The example here detects a CUDA call and changes it to HPU. HPU modified is for CUDA calls that don't have a one-to-one matching. We map it to a related Synapse API related call. For this example, the Torch CUDA float tensor has a HPU related call through Torch float tensor. HPU mismatch are calls that are currently not supported with the Gaudi implementation, so we'll raise an exception or inactive call. If the HPU mismatch does occur, then it is recommended to modify the mismatching function. You can refer to our docs where we have a table of supported APIs with HPU. We have examples of models using the GPU migration toolkit available on our GitHub repo model references. Here we have examples from simple MNIST to complex models, such as Stable Diffusion and Bloom 13b. Now we will proceed with a live demo of migrating a PyTorch model to run on Gaudi. We have a list of workshops and tutorials available on our GitHub repo, and today's example can be found at github.com/habanaai/gaudi2-workshop. Here we have a Jupyter notebook where we're running a ResNet 50 PyTorch model that is currently using CUDA calls, and we'll be using the GPU migration toolkit to run it on Gaudi. First step is to clone our model references, where we have our example code, and then set the appropriate environment variables, which we are setting the path of our model references and appropriate Pythons, Python 3.8. From there, we will navigate to the directory of the model, which is located in Model References, PyTorch Examples, GPU Migration, Computer Vision, Classification, Torch Vision. We have already pre-downloaded a dataset But you can follow the link provided here to download the appropriate dataset for the Resonant 50 model. Now we can look into the training.py Python script. Here we have imported the GPU migration toolkit library, as well as appropriate Habana torch libraries. Next, we can see that mark step is placed appropriately right after the optimizer step and lost backward steps. From here, we'll be running a 8-card Gaudi 2 run with a batch size of 256 running the Resonant 50 model. And as you can see here, the device is currently being used as CUDA, and we have the right data set, and we're running for 1 epoch. From here, we can see that we have enabled the GPU migration log levels, so we can see what's occurring. And we can see the replacements of all the CUDA calls with the appropriate HPU calls. In this example, we can see a lot of HPU matches, which means it replaces any one-to-one mapping, for example, nickel to hickel, as well as any CUDA to HPU calls. And from here, it proceeds to go through the training, loading the training data, setting up the model, and we'll continue to start training, as you can see, and then finishes up with some cleanup. That concludes the demo of the Gaudi 2 GPU Migration Toolkit. Here we have the Intel Gaudi collateral. We have a developer, the Habana.ai, that contains information about our performances, tutorials, and latest news and events. We have in-depth documentation and guides in our docs Habana.ai. If you have any questions or concerns, we have our service desk and forum websites that can help answer your issues. For examples of codes and models, you can refer to our model references repo on our GitHub or our repo available on Hugging Face's Optimum Habana. To get access to Gaudi 2, you can go to the Intel Developer Cloud and follow the steps in the Getting Started section. There is a video walkthrough of the Developer Cloud Quick Start to help you get started using Intel Gaudi 2. Thank you for watching.